Hello, my name is Kang, and today we'll be doing a presentation on fake physics with the three people in my group, consisting of me, Kang Jing, Go Zhuohui, and Muhammad Akil bin Asmin. So, without further ado, let's get into the presentation. I will be presenting the theory part for our fake physics model, and what would fake physics be in your opinion? Fake physics, in my opinion, is when game physics may or may not align with real life, and in some cases may even be completely fictional, made by the developers to act as a stand model for an actual physics model. Fake physics is useful for semi-realistic games or even simulator games, for example, and it can be used in many models, such as maybe futuristic movement or simulator games, for example. So, I'm sure many of us have played Call of Duty Advanced Warfare. Maybe you would remember, for example, ball running mechanics, just to say the least. There are a lot of mechanics that I would consider futuristic and may or may not be considered fake physics due to the model in which they run on, which may not actually be possible in real life. Therefore, it can be considered as fake physics. Some of us have definitely played simulator games, maybe Microsoft Flight Simulator or DCS World Steam Edition. Some games like these, like Flight Simulator, for example, it may or may not necessarily be Microsoft Flight Simulator, but there are some simulator games which use their own physics models, which may or may not be realistic, in my opinion, that can be considered fake physics due to the enriched model in which they use their physics model, and as it does not align with real life, it can be considered fake physics in my opinion. Highly renowned games are known for the implementation of fake physics, and there are many examples which I'm sure some of you can think of, such as maybe Garry's Mod, Titanfall, Overwatch, Astroneer, just to list a few games, maybe even Apex Legends if you think of it. Some games like Titanfall, for example, have fake physics like wall running mechanics, which is probably not possible in real life, but in Titanfall, it is an example of how fake physics can be used to make the game good. Something like Astroneer with their fake gravity models can also be a good example of how fake physics can be used to create good games. So, how can fake physics be exploitable? Source Engine is a prime example of fake physics being unrealistic and exploitable. And for example, we will take wall running. Wall running is quite a good example of how it can be a good, but also unrealistic or exploitable by players. If it's done right, it can be quite a creative movement mechanic as seen in Titanfall 2, as in the GIF you can see here. It can be yeah, you can use it to move around maps faster, maybe explore places of the maps that you have not seen before, but it can be exploited by players to exit boundaries that have been created by the developers, and it can be used to maybe access a hidden part of the map that the developer doesn't want anyone to go into, and it could possibly break the game. So, this is one example of how fake physics can be exploited by players to do the game bad. So, the problem that we are trying to solve on fake physics is on mirror reflection in games. In the past, old PlayStation games did not have reflection rendering, but instead would create an entire separate copy of the room on the other side of the mirrors, which would take up a lot of GPU, which would tax GPU a lot basically. We will solve this problem by implementing our own fake physics for mirrors, and for the rules of our mirror, we shall list it in the next slide. So, what are the rules of the simulation that we have created for reflector space? For our simulation, objects in the reflector space will not be projected until the mirror is removed. To demonstrate this, I will use a tissue paper as a mirror. So, objects in the reflector space will not be projected until the mirror is removed. So, let's say this is our mirror. So, if we were to take an object and put it here, it will be reflected, but it will not be projected on the other side of the mirror until the mirror is removed. Then the object will be projected. Will be like created on the other side of the mirror, basically, on the plane of existence. Object in the reflector space will be projected into the same point in space mirrored. So, what we are trying to say here is, let's say we have a mirror here, and we have an object. So, it will be projected in the same point in space mirrored. So let's say if it's in the middle, it will be in the other object will be in the middle in the mirror. And if it's removed, let's say the mirror is removed, it will be projected like this here. So it'll be together basically. Objects cannot be moved. That's quite simple. We cannot move the objects in our space. If there's an entrance, the projected mirror entrances will lead to the same point in space, the original entrance endpoint. So, take Portal for example. I'm sure some of us have played Portal. It's a Valve game. It's a great game created by Valve. Let's say if I were to have a mirror here, and there's a door here and a door here. Okay, let's use this. If we have a door here and a door here, let's say, and this door leads to, let's say, some point in this place, like here. So, this side, the door, will lead to the specific point. But the reflected place, well, let's say I remove this, the door here, will also lead to the same point. So basically, no matter, even if it's reflected, the endpoint will still be at the same point, basically, yeah. The person's perception of the object in the mirror will never change. So, no matter how the person looks at the mirror, like just looking around, it will never change. It'll still look the same. Only when the mirror moves does the object in the reflected space move either closer, angle, or further. So as we said just now, the person's perception of the object will not change, so you'll keep seeing the same object no matter where you're looking from. But only when the mirror moves does the object in the reflected space move to your own eyes either closer and it becomes angled, or it goes further. So that is the rules that we have created for our simulation. And what will we require to do this? We'll require a rigid body, a main camera, textures to render, materials, maybe the boxes or whatever to create the scene, the vectors, and of course a raycast. And for the implementation, we'll lead this to I will be bringing this on to my next teammate, Gojo Hui. So thank you very much for listening to my part. Thank you.
Hello, my name is Go Hui, and today I'll be presenting my part on the GMAPS presentation, which is implementation of the mechanic. So, our mechanic that we're going to be implementing is reflection. So, how many games? There are many games out there that basically try to have a mirror that reflects a person or objects within the room. Like as above, you can see in Super Mario 64, you can see Mario being reflected to a mirrored glass that looks almost like a clear glass. There are many games that warp space and reality, but our mechanic would be to be focusing on the perception of mirrors or how we see mirrors. So if basically mirrors reflect objects in real space into a reflected plane. And however, if we are able to see the mirror as not something that's reflecting something in real space, but much rather a clear glass with objects on the other end, it could make for some interesting games, and that is the mechanic that we'll be developing on. So here's a demonstration of the mechanic that I've made for myself in Unity. So a few things. Currently, I'm in first person, so this is a first person type of game. You can see there's a mirror that's reflecting the objects, and depending on how we are viewing the mirror, reflects the objects differently. And when I click my left mouse button, it will then create the objects into real space, as if that the mirror itself was simply just a clear glass that the player is looking through, as if the objects were there in the first place. The next part, you can see that behind the mirror, there's actually nothing. And much rather is that the mirror is simply creating the objects that it's reflecting into real world space. So, as you can see here, I look behind the mirror and there's nothing. I shifted up the objects a bit so that even as the objects are changed, the mirror would still project the same objects like that. It makes it seem that it just creates the reflection and duplicates the object into the real world. This main mechanic here required a lot of vectors and understanding of how light works and reflection. Some parts of the code that I'll be going through later showcases some aspects of how I managed to get this mechanic to work. But essentially, it is simply taking those two objects there and duplicating. And As you can see, the mirror is currently reflecting only one object. So even when the player is perceiving the mirror as there's only one object there, then it will only create one new object as it's simply only reflecting one object. As you can see, it creates one object there, and the other cube is not spawning as it is not part of the reflection. And that's it for the mechanic. Move on to some important code. The first code is related to reflection, how I managed to replicate a mirror's behavior. So how the mirror works is actually it has a camera attached to the mirror itself and a render texture. So the texture would basically render whatever is seen on the camera onto the plane, which is the mirror. So whatever you see on the mirror is simply just another camera. I made it such that the player would constantly fire a raycast towards the mirror, and it would then reflect away from the normal and make the camera of the mirror face toward the reflected raycast, so that it simulates how light would work, where it would fire from an object to the mirror and into our eyes, so that no matter how we are looking at it, it would change the reflection. So you can see I use rotations, vectors, and vector tree reflect. For the next part is reflected objects, how I managed to get the objects that are being reflected. So I take every single object that is inside the field of vision in the camera for the mirror, which is by using roll to viewpoint point, which basically translates the objects within the FOV into roll point. And if it's within a 1, basically 0 to 1, which means that it's currently in the field of vision, then I can add it to a list for reference in the final part, where if I click my left mouse button, it duplicates the object. So by firing raycast from the objects towards the mirror, I then refract it in. So instead of reflecting it outward from the mirror, it goes in so that I can predict where the object will end up inside reflector world space. So this is all the code for it. The raycasts, the vector reflect, and instantiating the object. Yeah. And so that is my part on implementation. I'll move it on to game mechanic by my friend Akil. Thank you.
Hi everyone, I'm Akil, and today I'll be guiding you through the game mechanics section. As shared previously, we managed to implement a convincing mirror into Unity without the need of a physics engine, ray tracing, or external libraries. Essentially, we implemented a sort of fake physics by recreating how light and reflections work. However, notice we also added a unique feature where we can summon the reflected objects into world space. Can't we turn this feature into something bigger, like a puzzle-solving tool? Through this game mechanic, we built an idea of a 3D puzzle adventure game which challenges the player on their understanding of mirrors. Before we get into the game details, let's establish a basic understanding of how object cloning using mirrors would work. The player can duplicate objects by projecting its reflection through a mirror. How he sees the object in the mirror, such as its orientation and distance from him, will appear in the real world at the exact same spot. Remember this diagram from secondary school? It's like that, except the mirror image is now a real object. To put it simply, both object and clone will have the same distance from the mirror. An object 5 meters away from the mirror will be 10 meters away from its clone. This rule is vital and remains consistent for every mirror interaction you will see later on. As such, the real challenge of the game comes from finding the right angles and positioning of both the player and the mirror. Let's run down the specifics of our mirror so that we can understand its interactions with full clarity later in our prototype. The player is in a 3D environment with first-person controls. In the environment, objects that can be duplicated are explicitly marked with yellow. The player carries around a square mirror the same height as himself. The mirror is also reflective on both sides. The player can place the mirror a short distance away from himself. When placed, it appears perpendicular to a surface like the floor, wall, or ceiling. It can also turn on the ground to the player's liking. After deciding mirror placement, the player can look at an object's reflection in the mirror. The reflection is highlighted once it is fully bounded by the mirror and has clear line of sight to the mirror, i.e., not partially obstructed by walls, etc. The mirror then flashes to glass while the reflection remains highlighted, showing an example of the reflection as a real object in the environment. If the example object is obstructed by the environment or does not have a clear line of sight to the mirror, the example object flashes red and cannot be created. Otherwise, the player can create the example object, aka clone of the real object, by pressing a button to remove the glass pane regardless of its distance from it. An object pair, original and clone, appear monochrome and cannot be duplicated again, for simplicity's sake. However, you can reclaim one to duplicate the other again, effectively allowing you to move objects. The player can only reclaim objects a short distance away from itself. To reiterate, here's the list of criteria the player needs to fulfill before being able to clone an object. Now let's go over the multiple level scenarios. Scenario 1, facing the mirror straight. Okay, so the first level is there's an elevated platform and the exit is on top of that platform, and there's a box just far away enough that the player can't jump onto the box and onto the platform. So the player must somehow move the box closer to the platform to get up and to the exit. So the obvious solution here is to just go behind the box and place the mirror in front of the box, and then use that and clone the cube to make it up to the next platform. In scenario 2, we face the mirror at an angle. So it's the same premise as earlier, but now there's a wall blocking the cube, and we can't just put the mirror in front of the cube. However, we can put the mirror beside the wall, and look at the mirror at an angle to place the cube's clone in between the wall and the platform, so the player can get up onto the platform. Okay, now we're tilting the mirror, so that there's a chasm and the player has to get off to the other side of the chasm to reach the checkpoint. So in this case, the player needs to rotate the mirror by like 45 degrees and get the right angle so that the clone can be placed across of the chasm, so it can walk across the chasm and reach the checkpoint. Okay, then there's also a scenario where we have to reclaim the clones. So in this case, there are two platforms, and in between those platforms is a cube, which will be used to solve the puzzle. And the player needs to collect a key before he can open the door and beat the level. So first off, he just does like the first scenario where he just duplicates the object straight forward, and he can jump onto the clone and reach the key. And now he can fall down and reclaim that clone so that the original object is in the same spot. And then now he can mirror the object again to get onto the other side with the door open. So now that you understand the potential of this game mechanic being used in example scenarios, how about we spice it up a little? Take for instance Portal, where the levels are enhanced by many other mechanics such as the hard light bridges and the anti-gravity excursion funnels, instead of just the portals alone. Can we add our puzzle elements with reference to mirrors and objects duplication? We definitely can. So we wrote with the assumption that we could place the mirror on any surface like the ceiling, but that may not always be the case. We might want some versatility with the level design. For example, we will want the function of a solid wall, but prevent the player from placing mirrors that will create unintended level solutions. Whenever the player clones an object, they must always obey the line of sight rule. What if the walls were not always opaque? With glass walls, we enhance level design by having the function of a solid wall, but being able to bypass this rule. Cloned objects always appear as a pair. What if we take this rule of pairs and turn the objects into teleporters, which exclusively exist as a pair? When cloning a teleporter, the cloned counterpart serves as a destination, whereas the original, the origin. Although they can be interchangeable at the discretion of the level designer. Rule of pairs, you wish. Objects do not necessarily have to be limited to one clone. We can have multiple to improve level design flexibility. Other than that, it can be a form of shock to the player as we break their belief of the rule of mirrors. Of the rule of pairs. By accomplishing a task like replicating a mirror through code, the process inspires us to create entirely unique mechanics. Through fake physics, we built an idea for a game that shares similarities with Valve's Portal games. I hope this inspires you guys to explore and be open-minded towards niche or obscure concepts so you can design more unique games. Thanks for watching.